is looking bad. This is looking very bad.
It's working now.
No, but it's this that's not working. Maybe it's my cable. Does anybody have for their iPhone like one of these cables? USB, mini USB? Like on their phone? No? Nobody has something like this to charge up their phone?
Android phone.
I don't know, it's the mini USB to the normal USB.
The mini USB for iPhone and
That's for iPhone.
Is that for iPhone?
Yeah, I think so. Yeah, it's like the iPhone.
I have one in
Maybe.
this one.
Maybe.
Is this one?
Maybe this one. Let's see. Oh, it didn't work. Right. No. This is broken. So what I'll do is I'll type. It's okay. I'll just type. So I'll need to buy a new one of these. Yeah, oh no, I'm not paying for it myself. Well, I got 3 years out of it, that's not too bad. Okay, so for our arithmetic progression, we call the first term A, small a please. Ricky.
Albert.
Come on. Right, so write this down. For a arithmetic progression, we call the first term A, and the difference between the terms D. A is called the, I'll zoom out a bit. Can you see that okay, or is that too small? I need to make the font a bit bigger, huh? Is that okay? Yeah. Shunwei, can you move the projector a bit to the right? Yeah. So we call the first term A and the difference between the terms D. A is called the first term. And the D is called the, I think you said it, Malik, common difference. So the vocabulary that you need so far is that A is called the first term and D is called the common difference. So, the first term is A. What's the next term? A plus D. The next term? A plus 2D, A plus 3D, etc. So for example, if you had a sequence like 1, 3, 5, 7, here, what's the A? 1. And the D? 2. So we'd like to find a formula for this sequence.
You mean nth term or?
Yes, exactly, the nth term. So if you look at the sequence, I think you can figure out the formula. The first term, U1, is equal to A. The second term is equal to A plus D. The third term is equal to A plus 2D. The third term is, the fourth term is A plus 3D. Fifth term You add d again. A plus 4d. So what's the nth term?
A plus
And D.
Not quite.
A plus
N plus
D
1.
multiplied by
N
n
minus
minus
1
1.
D.
N minus 1d. That it's always one less. So this is your first formula. Yeah. Okay. So we have only two formulas to do. The first is to find the nth term. So this is the formula for the nth nth term nth term of the sequence. So now the next formula we want to do is how to add each term. So next we want a formula that adds all the terms together. So for example, we want a formula that can let you calculate the sum of all the terms, etc.
Can be finite and infinite.
This, for arithmetic, it cannot be infinite, but for geometric, what we'll do next time, it can be infinite. Yeah. Okay. Yeah, so UN is A plus the second term, which is A plus D, plus the third term, which is A plus 2D, plus the next term, which is A plus 3D. And then this continues all the way until the last term you want to add. So what's the nth term? A,
N
not quite that.
N minus 1.
Yeah, n minus 1 d. Now what I'm going to do to get this formula, the proof, so this is like, if you want to think of it as a new section, finding the formula for the series, whereas this one here, I suppose you could say it's like finding the formula for the nth term, and this one here is a little bit of an introduction. Okay. So the trick here for finding the formula is you write out the problem again but backwards. So you start at the back. A plus n minus 1d. And what's the next term? Or the second last term?
Minus 2.
Yeah, a plus n minus 2d. And then you continue until you have the first three, which are now the last three. A plus 3d, a plus 2d, a. Some people maybe have seen this proof before. And then what you do is you add both lines together.
Almost a
Yeah.
plus D.
Yes, a plus d plus a. A little bit more space there. And the reason I changed this to an S is S is for series. You want to add them together. Okay, so what happens when I add the first two? That's this one and this one.
The same number.
Nearly the same. So you get A.
The last term. Like the value of the last term.
Yes, well, we'll see now. Okay, so if we add the first two together, I'm adding A plus n minus 1d. I'm adding this one together with this one. Can you see that? So I'm adding these two together. What does that become? That's 2a plus n minus 1d. Now let's add the next two. So I'll put them in a different colour. So I'll add the next one, which I'll put in a kind of a blue, with this one here.
Is it too blue?
Whatever colour it is, I don't know. Bluish. So A plus D plus A plus n minus 2D. That's 2A plus D plus nd minus 2D, because you can expand this here. That's 2A. Now here there's a D in common, so you can have 1 plus n minus 2D. You see, I could take the D out from here, here, and here. So what does this part become? N minus 1. So what I want you to notice is that the answer I got here is the same as the answer here. In fact, each time you add these together, you always get the exact same result. So when you add all of these together, I'll go to a new page. Okay. Back to black. So when I add these together, Sn plus Sn is 2. Black, please. 2Sn equals. Now, how many of these pieces do you have when you add them all together? How many will you have of these?
N over 2.
The half.
N over 2? I don't think N over 2.
Why?
Well, here this is once, this is twice, 3 times. So there's N. I think there'll be N altogether.
But you add the first one and
The first one here plus the first one here, yeah.
yeah, it's
How many terms are here in this list?
N.
N. And how many are here?
N.
N. So what I'm doing is I'm adding the first one with the first one, the second one with the second one, the third one with the third one, all the way up to the nth one with the nth one. So here I'll have answer, 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 dot, 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 answer, all the same. There's n of these. No? Are you sure? You don't seem happy with it. Is that okay? N of them. So I have n times 2a plus n minus 1d. Because I have n of these. So if I add them together n times, I just multiply by n. You know, if you have like 3 plus 3 plus 3 plus 3, you have 4 of them. They're all the same, so it's just 4 times 3. So it's the same idea. Alright, there's only one thing.
Choose different x better, so
Yeah. So.
oh yeah, you because you put the 2 before the Sn.
Yes.
Yeah.
Yes. So now I have Sn equals. So if I divide by 2, yeah, n over 2 times 2a plus n minus 1d. Now this formula I'm sure looks familiar to some people. This is the formula for the series. Yeah. So I suppose that should be put in the center. Okay. Right, so just write this one down, and then we'll have a look at some examples using this formula. Okay. Got this? Yes? How many people am I missing now? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Nina, Pony, Albert. Okay. Right, can we go down to the first example, example 1? So this sequence here is arithmetic, and my question is, what is the A and what is the D? I think you should be able to see this. So the answer, the A is, who can see it? 0, you start at 0, and the common difference, the D, is 4, because you're adding 4 each time. That's a simple example to get us started. Example 2. Find the nth term of the sequence minus 9, minus 14, minus 19, etc. Okay, so what I mean here is your answer will have n in it, because I'm not telling you what the n is. So when I say the nth term, I'm not saying which term. So I could mean, the first, second, third, 100. I'm not saying. I'm just saying the nth term. So firstly, can I scroll down a bit, guys? Can I just go to like here? Right. So firstly, what's the A here? Minus 9. Good. And the D? Minus 5. Now, if you have trouble seeing what that is, you can always find the D by taking the second term and minusing the first term. Or even the third term minus the second term. Anyways, that's the A and that's the D. So, do we remember the formula for UN, the nth term? Yeah, it's A plus n minus 1D. The A here is minus 9. The D is minus 5. So when you expand here, you get minus 9 minus 5n plus 5. So you get UN equals, now we can simplify this a bit, minus 4 minus 5n. So this is the answer here for this one.
The form, like the equation of the third.
Yeah, like the formula for the nth term. Can you close the blind? I think there's a bit of a shine on the board. Can everybody see okay? We'll close it just in case. That's better. Okay, so if you look at this formula, if I put n equals 1, what do I get here if n equals 1?
No, it's minus 9.
Minus 9. That's correct. If I put n equals 2, I get minus 4 minus 10 minus 14, which is also correct, and so on. So this this formula can make any term in the sequence, the nth term. Okay. Next example. So how many terms are in the sequence 9, 18, 27, ... up to 126? Right, does anybody have any ideas how I can do a question like this?
Find the nth term.
Huh?
Formula first.
Yeah, so you're saying find the nth formula first, correct? And your idea, what are you going to say? No? He stole your idea? You go on, you said find the formula for the nth term.
Yeah, by using the first term and find the
Yeah.
common difference.
And then?
Substitute it with 1 to 6.
That's it, yeah, that's it. So first we have to find the formula for the nth term. So let's write it down directly. What's the a here? 9. And the d? 9 also. So that's 9 plus 9n minus 9. So what do we get? 9n. So the nth term un is just 9n. So for example, the first term should be 9. Second term should be 18. Third term should be 27. We don't know what number this is. So this is like the nth term. The nth term is 126. But the nth term is 126. Therefore, you can say un equals 126, which means 9n equals 126, which means n equals 126 divided by 9.
126.
Why do I keep doing that? 126 divided by 9, so n equals 14. So 126 is the 14th term. That is U14 equals 126. And if you did it the long way, if you kept adding 9, you see after 14 terms you will get to 126. What happens if you got an answer like this, 14.2? What does that mean?
It's wrong.
Yeah, it means you made a mistake, or there's a mistake in the question. Yeah, because here n should be always a whole number, a natural number. Yeah. Okay. Next example. Example 4. Find the A and the D if the 7th term is minus 13 and the 17th term is minus 23. Yeah. So we start off, all we know is 2 terms in the sequence. We know that the 7th term is minus 13 and the 17th term is minus 23. But this is enough information to find the A and the D. You only need to know 2 of the terms to find the A and the D. So the first one, the 7th term is minus 13. And then the 17th term is minus 23. The 7th term is this, U7, and that's equal to minus 13. But what's the formula for U7? A plus 60 equals minus 13. So by using the formula, we can say this. Let me put that in the center. Now, what is the formula, or U17, the 17th term, is minus 23. And again, by using the formula, we can say so what would it be in this case? Yeah, A plus 16D equals minus 23. Now, this should now be a problem that looks very familiar.
Substitution or elimination.
That's it. What are these problems called?
Nothing.
Yeah, what did I call them? degree 2 systems, simultaneous. So what method would be the easiest one here?
Elimination.
I think elimination, yeah, because the A's are the same. So I'll call this one equation 2, and this one here I'll call equation 1. So if you do equation 2 minus equation 1, okay, A minus A cancelled. 16D minus 6D,
10D.
10D. Minus 23 minus 13 minus 10. So what does the D equal? Minus 1. Now if you take this and put it back in here, you can get the A. So sub this into equation 1, and yeah, what do we get? Is it minus 7? Thank you. So actually, yeah, no, that's it. That's the answer. So isn't that what I wanted? The A and the D. Yeah. So there's the answer. D is minus 1, and then answer D is A is minus 7. Yeah. Okay. So far we've only used one formula for all these problems, the Nth Term formula. So now let's have a look at some examples where we need to use the series formula, the SN formula. So what example is this now? Sorry, do you have this? Can I go down?
Yeah.
I can write it here. Example 5. Calculate this S40. So what does S40 mean? What's S40?
And the first 40 terms.
The first 40 terms. So I tell you what the first few are. 8 plus 11 plus 14 plus 125. Plus, and then you skip many of them and finish at 125. So if we want to use the formula, we need to know the A, the D, and the N. So if you look at this sequence, you can see what the A is. What's the A? 8. No problem. What's the D?
3.
No problem. And the N? 40. So let's use our formula. The formula is N over 2A plus N minus 1D. So that equals, let me see, 40 divided by 2. 2A, that's 16, plus N minus 1, that's 39, times D, which is 3. Okay, so that's 20 times 16 plus 157. Yes, 117. Fail. 117. And that equals 20 times 117, 133. Yes, 133 here. People with calculator, person without calculator. Yes, 133. So that's equal to 2660. Yes? So if you add the first 40 terms here, you'll get 2660. Yeah.
125 is the value of term 40 or?
Yes, it's the 40th term. Yeah.
Can we calculate like the sum if we add 8 and 125 only?
Yes, that's what we'll do next. Yeah. Just before we do that, let me just prove to you that this formula works. So what was the first term? 8. And the next term? So you add how much? 3. And then we go up to the 40th term. What should the 40th term be?
1 to 5.
And it is. So if I use Excel here to add all of these up, I should get, what was it, 2,660, and I do. So you can see that this formula works, definitely works, and it can be really useful for very large add-in problems. Yeah. Now, so as you said, can you do this with less information than this? And that's actually the next example to have a look at. So example 6 now. So what is 5 plus 13 plus 21? Now, sorry, example 7 I think is the one you want. So this one is a little bit before that one. What is the sum of 5, 13, 21 up to the nth term? So here I'm just asking you, I'm not telling you where to stop. So in this example, what's the A?
5.
The A is 5. The D is 8. And here the N is N. I'm not telling you the N. Okay. So if we use our formula, Sn is N over 2a plus N minus 1d. That is N over 2, 10 plus 8n minus 8. That is N over 2, 2 plus 8n. Now there's still one thing left to do to simplify this.
Multiply by n and divide by 2.
Yep, you can multiply by the n and divide by 2. So we'll divide by 2 first, and you're left with 1 plus 4n. And then, as you said, multiply in the n. So what do we finish with? N. Yeah, 4n squared plus n. This is a square, of course. So just to prove that this formula works, for example, how many terms do I have here? 3 terms. What do you get if you add them together? 21 plus 13 is 34, plus 5 is... No, that's not right. No, 34 plus 5, 39. Yeah? So if I put n as 3 here, I should get the same result. So 3 squared is 9. 9 times 4, 36. Plus 3, 39. So this formula works as well. Okay, now on to the one I promised you. Example 7. Calculate this. Minus 8, minus 11, minus 14, many more terms, minus 113. So what's the big difference between example 7 and example 5?
You have n.
Well, minus is one difference. Yeah? Go ahead, what did you say?
The previous example, you have the n.
Yes, and here?
You don't have it.
We don't. Is there any example that's like this one where you don't have the n? What do you think? I mean, the problem here is you don't know the n. But have we done an example where you can find the n? Yeah. So, the a is no problem. What's the a here? Minus a. And the d is no problem. What's minus 3. But what the big problem here is the n. You don't know what the n is. But this is just like example...
You can do it 2 steps or just 1 step.
which one, the n?
Yeah, you have to find the n.
Yeah.
And like substitute in.
That's it, yeah. It's like example 3, finding the n. So, what's the technique? What do I do? Well, I say the nth term equals minus 113. So what's the formula for the nth term?
UN
Un equals, yeah,
8
a, which is minus 8, plus
n minus 1
n minus 1, d, which is minus 3. That should equal minus 113. So you have minus 8 minus 3n plus 3 should equal minus 113. Yes, that's right, isn't it? Minus 3, yeah. Minus 5 minus 3n should equal minus 113. Minus 3n should equal minus 108. So then n equals 36. So what you can do is you can take this answer and now bring it back up here. N equals 36. Now do you have enough information to use your SN formula? Yeah, we do. So do you need me to do that actually, or can I just go? I mean, it's now just like example number 6. You just put the numbers in the formula. Do you need me to do that, or will I just go to the next example? No, I think that's okay, isn't it? This was the difficult part, trying to get this information. So I'll just write here, now we can use the SN formula. Okay. Next example. Example 8. No, it's not 98. Okay, so here is the sum of that's worse. Right. The sum of the first 19 terms is 228, and the sum of the first 22 terms is 297. Find A and D. Okay, so this is a bit like which other example? This is a little bit like the example 4. Except the only difference is, instead of using the UN formula, you need to use the SN formula, because I'm talking about the sum. Okay, so let's have a look at this here. Right, so you have the sum of the first 19 terms, S19 equals 228, and S22 equals 297. Okay, what's the formula for S19? Well, that's 19 over 2, 2a plus n minus 1, what's that? 18d. That should equal 228. And the sum of the first 22 terms is 297. So 22 over 2 times 2a plus n minus 1, which is 21 now, d is 297. Okay, let's clean these up a bit. So I can bring this to the other side and make it a 2 over 19. And I can bring this to the other side and make it a 2 over 22. Can somebody calculate those numbers there? Are they nice numbers or ugly numbers? That's a nice number. 2, and divide by 19? 24. Okay, and then on the other side? Sorry, let's just say D, of course. Now, what type of problem is this? What type of problem have I made it now? It's system, isn't it? So what method do you want to use? What's the best method here? Elimination. So the second minus the first. So 2a minus 2a, gone. 21d minus 18d, 3d. And 27 minus 24, 3. So therefore, d equals 1. And I can get the a if I sub it back into like into here. A will be 24. A is 3? Yeah, A is 3. If I just sub it into, say, this one, for example, I can get the A. Sorry, I know I'm running a bit late. I had technical difficulty at the start. Well, have you got a class at 10?
Yeah.
In this room? No, because I'm in this room. Where are you next? Downstairs? Alright, I have one last example to do really quick and then you're finished. Example 9. Find x if 2 plus 9x, 3 minus 4x, and minus 4 plus 6x are in arithmetic progression. Okay, so the last one here, I'm telling you that these three numbers, this is the first number, so whatever, orange, this is the second number, purpley colour, and then the third number, whatever, blue. So these three numbers are in arithmetic progression. So if you think back to the start of the class, as I was saying, arithmetic, what do we know if something is arithmetic progression? What's the relationship? Yeah? Next number is equal to the last number plus a constant. So what do you think you can say about the second number minus the first number? It should be the same as the third number minus the second number. That the second minus the first should be the same as the third minus the second, if they're in arithmetic progression. Yeah? So that means I get 3 minus 4x minus 2 plus 9x should equal minus 4 plus 6x minus 3 minus... did I make a mistake? No. Are we good?
So you just like the first one plus the minus one divide by the in the middle.
The first one plus which one?
The first one.
Yeah.
2 plus 9x.
Yeah.
Plus minus 4 plus 6x.
Yeah.
Divide by 3 minus 4x.
Oh wow, it's complicated.
You don't get the d?
The first one.
Oh, but you don't know the d. It's not what.
Yeah. And that sounds much more complicated because of the divided. First one plus the third one divided by the second one. That scares me. I don't want to do it that way.
No.
Yeah.
2 plus 9x.
Yeah.
Plus minus 4.
Yeah.
Plus 6x.
Yeah.
Divide by 2 equals 3 minus 4x.
You're saying that the first one plus the third one equals this one divided by 2. Correct. That will give you the exact same answer. You're right. So you could say, and in fact you can see that here, you could rearrange this into the first one plus the third one equals twice the second one. So in fact, what you're saying will give you the same equation after you rearrange it. But I think this is a tiny bit easier because you don't have any division. Yeah.
It's only divided by 2.
Yeah, I suppose. Yeah, it's only divided by 2. Yeah, that's fine. That's fine. Yep. If you want to do it that way, that's no problem. It'll give you the same answer. Yeah. Okay. I don't think I need to finish it because what type of problem is this now? What's it called?
Algebra.
Yeah, basic algebra. It's a basic linear equation, isn't it? 3 minus 4x minus 2 minus 9x equals minus 4 plus 6x minus 3 plus 4x. This is middle school. You know how to finish this, don't you? Just rearrange it and get the x, which is what I wanted. Okay, so I mean there's boring maths stuff here. Find x, middle school, and that's it really. Okay, so I know that was a little bit rushed, but we have the tutorial tomorrow. So if we need to practice more examples in the tutorial, we can do that. Because I think the last 2 lessons weren't too difficult.
Are we going to do the